Time travel, the ultimate puzzle. Time travel has always been one of humanity's most fascinating ideas. From ancient myths to modern science fiction, the ability to journey through time captures our imagination like no other concept. But if it's possible, why haven't we seen any proof? Why hasn't a time traveler shown up to change the course of history or to tell us about the future? Let's dive deep into the theories, mysteries, and possibilities that surround the tantalizing concept of traveling through time. The legend of John Titor. In 1998, an enigmatic figure named John Titor appeared on internet forums claiming to be from the year 2036. His story wasn't just any tall tale, it was steeped in technical details. Titor claimed to be a soldier sent back in time to retrieve a 1975 IBM 5100 computer, which he said was critical for debugging legacy systems in his future timeline. This mission was tied to an apocalyptic event that he said would fracture society. Titor described his time machine, the C-204, in vivid detail. He claimed it was equipped with micro-singularities capable of bending gravity and space-time. Installed in a car for mobility, the machine could allegedly take him up to 60 years forward or backward. Titor's posts sparked a flurry of interest, with people scrutinizing his predictions, including a U.S. civil war and nuclear conflict. But by 2001, Titor disappeared as mysteriously as he had appeared. Was he a genuine traveler or simply a clever prankster? The debate continues. The science behind time travel. To understand time travel, we need to start with Albert Einstein's revolutionary theories of relativity. In Einstein's view, time is not a constant. It's a dimension intertwined with space, forming the space-time continuum. Gravity, as described in general relativity, is a curvature of the space-time fabric. And this curvature doesn't just bend space, it bends time as well. This means time isn't fixed. It can be stretched, compressed, or altered. For instance, clocks aboard satellites orbiting Earth run slightly faster than those on the planet's surface due to weaker gravitational forces, a phenomenon known as gravitational time dilation. Black holes and time dilation. One of the most extreme examples of time dilation occurs near black holes. These cosmic monsters are so massive that their gravity warps space-time dramatically. If you were to venture close to a black hole like Sagittarius, a star at the center of our galaxy, you'd experience time at half speed compared to someone on Earth. This isn't just a thought experiment. It's supported by Einstein's equations and modern physics. In theory, if you could orbit a black hole safely, you'd effectively be traveling into the future. While years pass for observers on Earth, only a fraction of that time would pass for you. But the dangers are immense. Stray too close, and you'd be pulled into the event horizon where not even light can escape. Traveling at the speed of light. Another method of time travel involves velocity. According to special relativity, as you approach the speed of light, 300,000 kilometers per second, or 186,000 miles per second, time slows down for you relative to stationary observers. This phenomenon, known as time dilation, has been experimentally verified with particles in accelerators and atomic clocks on fast-moving jets. If you were on a spaceship traveling at 99% the speed of light, time would pass much more slowly for you. A year on your ship could equate to centuries passing on Earth. This means that traveling into the future is theoretically possible, but the technology required to achieve such speeds is far beyond our current capabilities. Wormholes. Bridges through time. For traveling backward in time, we turn to a more speculative idea: wormholes. These theoretical shortcuts through space-time were first proposed by physicist Albert Einstein and mathematician Nathan Rosen in 1935. Wormholes could potentially connect two distant points in space-time, allowing for instantaneous travel. However, wormholes come with significant challenges. They're believed to be incredibly unstable, collapsing almost as soon as they form. Additionally, the energy required to stabilize a wormhole would be astronomical, and it's unclear if they could ever be traversable by humans. Even if we could use a wormhole to travel back in time, paradoxes could arise, like the famous grandfather paradox, where altering the past might erase your own existence. Stephen Hawking's time traveler experiment. In 2009, the renowned physicist Stephen Hawking conducted a playful experiment to test the existence of time travelers. He hosted a party, but sent out invitations only after the event had ended. His logic was simple. If time travel is possible, someone from the future might show up. Hawking waited, but no one arrived. While no time travelers attended, Hawking's experiment raised intriguing questions. Could time travel be imprecise? Or is it governed by rules that prevent interference with the past? Perhaps time travelers exist, but avoid revealing themselves to prevent catastrophic consequences, or they might be operating under strict secrecy. The challenges of proving time travel. Even if someone claimed to be a time traveler, proving it would be incredibly difficult. They could predict future events, but skeptics might dismiss it as guesswork or coincidence. Showing futuristic technology could help, but how would we differentiate it from advanced modern inventions? Genetic testing could provide clues if they exhibit traits from a future evolutionary timeline. However, the most convincing proof might be to take someone with them on their journey. Why haven't we met a time traveler? There are several possible reasons why time travelers haven't revealed themselves. 1. Time travel limitations. Time travel may only be possible in one direction, toward the future. This aligns with the arrow of time dictated by the second law of thermodynamics. 2. Classified knowledge. If time travel has been discovered, it could be classified as a state secret, with strict controls to prevent misuse. 3. Temporal ethics. Travelers might avoid interfering with the past to prevent paradoxes or unintended consequences. 4. Physical constraints. Traveling back in time may require conditions we can't replicate, such as harnessing wormholes or manipulating exotic matter. 5. Missed opportunities. As Hawking's experiment suggested, time travelers might not be precise in their navigation, arriving too early or too late to make contact. Time travelers. Among us. Interestingly, astronauts aboard the International Space Station experience a form of time travel. Moving at speeds of 28,000 kilometers per hour, 17,500 miles per hour, they age slightly slower than people on Earth due to time dilation. The difference is minuscule, fractions of a second, but it's a real and measurable effect. Could more advanced time travelers exist? Perhaps they've integrated into society, avoiding detection. Or maybe they've left subtle hints waiting for us to piece together the puzzle. A glimpse into the future. As we approach 2034, the year John Titor claimed General Electric would invent time travel, the mystery deepens. Will we uncover the secrets of time manipulation? Or will time travel remain a tantalizing dream just out of reach? For now, we can only speculate, fueled by stories, theories, and our boundless curiosity.